All right, hello, this is Richard Anthony Marca, and this is for the eighth assignment of CSC313, Graphics and Visual Computing. This is from the Rendering Geometries, Bitmaps, and Animation book on page 255, where it is exercise 4.3-4, where we are to simulate water splashing. Our objective was to enhance the particle system to simulate splashing when the pan tilts suddenly or when particles collide with the walls. And we were to implement realistic motion on higher velocity for splashing particles. So I will be running this here. So let's do this. Now, before I show this off, for some reason on my laptop, using the same exact code, it runs different. It runs slower than everyone else who used it. So this is the water, it's bouncing around. But if I tilt this way, instead of just falling, you can see it bubble on the left side, how it's bouncing around, splashing around. And if I move, some of them are still up in the air splashing about. And if I move this way, up, some of the water is still splashing and now it's going down. Move it this way. I mean, it's going to be a little hard to see, but it's hard to tell when it hits the wall here. But once it does, you can see them bounce around a bit. And putting it back into the center. Oop. Again, this would look a lot better if, for some reason, if it went in normal speed, but unfortunately this is stuck in slow motion, so which is odd because this laptop is new with a very good graphics card, so it should be running well, but it just isn't. Just imagine this going faster, or play the video in fast 2 times speed and maybe it'll show how it's supposed to look. And this is achieved in the lower part of this file. And this is all thanks to the particle class, the apply repulsion, cake pan position Y, and update classes, which I will explain in the Word document. And here is the Word document. As you can see, the first 4 pages are going to have no real changes from the book. But once we hit the 4th page, we are going to see in the update pan tilt, there was a little bit of a typo in the book where they had these swapped. This was supposed to be max. Well, this in the book, they had this as max and min when it's supposed to be min and max. So we put that as a change. And then on the 5th page, you're going to see this big change where we added a GL disable for the depth test and a GL enable for the depth test. Which disabling this test means that the depth of the object will not be considered when rendering. So for this fluid dynamics assignment, the objects that aren't getting rendered are the bottom of the cake pan. That way it ensures it draws regardless of the other object's depth, like the water. And then we re-enable it at the end. We also added this for a little buffer underneath the pan. So that's why instead of 0, it's like negative 0.0001 because it's very small. So in this page, there's no change. This page has a change where we added pan boundary Y. Also, at least on my end, because it runs so weird, I had to change the repulsion strength from 0.005 to 0.05. And here's one of the main classes that we changed, which is public particle. So if we go towards the bottom of it, you're going to see that RET we added to the normal Y part of the division of the equation, plus 0.02f. And if we go down a little bit more, we can see that we added a few new variables. So we added a float of absolute tilt force x, which is just the absolute value of tilt force x, the absolute value of tilt force z, which is just the absolute value of tilt force z, and tilt force y, which takes both the absolute values of z and x. As long as they're over 0.01, you divide it by each other and then add them. We also added this function here, since we want to use v of y. So vy plus equals tilt force y times 0.2f. And here are my changes, which is I wrapped Vx dampening and multiplied it by 2.5, so it bounces more. Instead of having just y equals k pan position, we added this pan boundary to y, similar to how we have if map absolute value of z is greater than the pan boundary, if y is less than the pan boundary. So similar to but different. And I also wrapped the v of z to be multiplied by 2.5f. And that should be the last of the changes that we made to the original file. But we did add all the features as you observed. So that is the end of this video. Thank you for watching.